So in this video, we're going to talk about the domain of function equations. Well, the domain of a function equation is a set of real numbers excluding any number that makes the equation undefined or not a real number. So let's write the domain of each function in interval notation. So f of x is equal to x squared plus 3x plus 5 is an example of a quadratic function because the degree of this is 2. So, are there any x values that I could plug in that would make the function equation either undefined or not a real number? Well, the answer to that is no. So, in interval notation, I can write that as negative infinity to positive infinity. So let's go down now to the next example, which is an example of a rational or reciprocal function. Now, when is a fraction undefined? Well, when the denominator is 0. So I'm going to set the denominator equal to 0. Let's check to see if this is factorable. Are there factors of 12 that add up to be negative 7? The answer is yes. I can rewrite this in factored form as x minus 3 times x minus 4. Set each factor that contains a variable equal to 0. And we get x equal to 3 and x equal to 4. So if I plugged in x equal to 3 or x equal to 4 into this rational function, it would be undefined because the denominator would be 0. All right, so let's put these values on a number line. Both cannot be included, so it's an open circle. But every other real number would be okay. So every value in this interval or this interval or this interval. So now I want to be able to write what's shaded in blue into interval notation. So the first region, well, that starts at negative infinity and goes to 3. Or, well, second region, that's going from 3 to 4, but I cannot include 3 and I cannot include 4. Third interval, from left to right, it starts at 4 and goes to infinity. So this is the domain of this rational function in interval notation. All right, let's take a look at a couple of radical functions then. First off, h of x is equal to the square root of 5 minus 7x. Now, so let's refresh our memory for this. Now remember, I want it so that it's not undefined. So if I did this, if I did the square root of negative 16, that's not a real number, is it? That's 4i. So you know I cannot have negative values under the radicand. Well, the square root of 0 is 0. That's a real number. And if I did the square root of 16, that's equal to 4. So in other words, if my index is an even number, then the radicand must be greater than or equal to 0. So I'm going to use that piece of information then, and I'm going to set the radicand, which in this case is 5 minus 7x, greater than or equal to 0. So subtract the 5, and then divide both sides by negative 7. Now remember, when you divide by a negative number, you must switch the inequality sign. Now let's put this on a number line. So 5/7 is included, so I will have a bracket, and we know the smaller values are to the left. So in interval notation, I would start with negative infinity to 5/7, and that is a bracket. Now, you can always do it like this also, so I will show this very quickly. You can always write this as square root of 5 minus 7x for starters, greater than or equal to 0. I can square both sides, and that's still 5 minus 7x is greater than or equal to 0, and then you can solve it exactly the same as what I just did to the left-hand side. Either way, you will get the exact same answer. Okay, one other one I want to take a look at is a cube root. Now, similarly to what I did for the previous example, I want to write a couple of things out. So first of all, if I do the cube root of -8, well, the cube root of -8 is -2. -2 times -2 times -2 is -8. So if I have a negative under this particular index, I still get a real number. Well, the cube root of 0 is 0 because 0 times 0 times 0 is 0. And the cube root of 8 is 2. So in other words, when the index is odd, the domain is going to be all real numbers. So notice here my index is odd because it's a 3. Okay? I don't have to do a whole lot of work here. The domain is all real numbers. Okay? So in other words, if the index is 3 or 5 or 7 or 9, the domain is always going to be all real numbers, negative infinity to positive infinity. If your index is even, like our previous example was, then I'm going to have to set the radicand greater than or equal to 0. So make sure you pay attention to determine if the index is even or odd to let you know how to write the domain of that function in interval notation.